In this video, I'm going to discuss about cumulative distribution functions. The cumulative distribution function of a random variable x is denoted as fx, where the small letter x here is a particular value of the random variable x. Fx is defined as the probability of the random variable less than or equal to this particular value of x. This includes all the probability up to and including x. The cumulative distribution function fx for discrete random variable is equal to the sum of all the probability less than or equal to x. The cumulative distribution function fx for continuous random variable is equal to the area under the probability density function before x. Using the fundamental theorem of calculus, the continuous probability density function can be obtained by differentiating the cumulative distribution function. In this example, I'm going to show you how to find the cumulative distribution functions for discrete random variables. X is a discrete random variable with the probability distribution function given here. Find the cumulative distribution function for x and sketch the graph of the cumulative distribution function for x. To find the cumulative distribution function for discrete random variable, one of the easy methods is using a probability distribution table. In the table, we list down all the possible values of x and the corresponding probabilities. When x is equal to 1, the probability is equal to 1 over 29. When x is equal to 2, the probability is equal to 2 power 2 is 4 over 29. And when x is 3, the probability is 3 over 29. When x is 4, the probability is 16 over 29. And when x is 5, the probability is 5 over 29. From the probability distribution table, the sum of the probability before 1 or equal to 1 is 1 over 29. The sum of the probability before 2 or equal to 2 is equal to 1 plus 4, 5 over 29. And the sum of probability before 3 or equal to 3 is equal to 8 over 29. And the sum of the probability before 4 or equal to 4 is 24 over 29. And finally, the sum of all the probability before 5 or equal to 5 is equal to 1. Now I'm going to write the cumulative distribution function in mathematics function notation. When writing cumulative distribution functions, all the values of x must be considered, includes all the values of x less than 1 and greater than 5. So, for x is less than 1, but not included 1, the probability is equal to 0. When x is equal to 1, the probability is 1 over 29. This value remains unchanged from x equals 1 up to 2, but not included 2. When x is 2, the cumulative probability is 5 over 29. This value remains unchanged from x is equal to 2 up to 3, but not included 3. When x is greater than 3 or equal to 3 and less than 4, the cumulative probability is 8 over 29. When x is greater than or equal to 4 and less than 5, the cumulative probability is 24 over 29. And finally, when x is greater than or equal to 5, the cumulative probability is equal to 1. So therefore, this is the cumulative distribution function for the discrete random variable x. Now I'm going to sketch the graph of the cumulative distribution function. So now first I get ready the x-axis and the y-axis and using the suitable scale. So for the first interval, when x is less than 1 but not included 1, the cumulative of the probability is equal to 0. And when x is in the interval 1 to 2, included 1 but not included 2, the cumulative probability is 1 over 29. And when x is in the interval 2 to 3, included 2 but not included 3, the cumulative probability is 5 over 29. When x is in the interval 3 to 4, included 3 but not included 4, the cumulative probability is 8 over 29. And when x is in the interval 4 to 5, included 4 but not included 5, the cumulative probability is 24 over 29. And finally, when x is greater than or equal to 5, then the cumulative probability is equal to 29 over 29, which is equal to 1. So this is the graph for the cumulative distribution function for x. In this example, I'm going to show you how to obtain the probability distribution function for a discrete random variable from a cumulative distribution function. To find the probability distribution function for x, since x is a discrete random variable, so the possible values of x must be exact value. So from this cumulative distribution function, notice that x is equal to -2, x is equal to 3, x is equal to 7, x is equal to 10, and 13. So for each values of x, we are going to find the probability. First, when x is equal to -2, we are going to find the probability when x is equal to -2. To find the probability, we are going to use the cumulative in this interval minus the cumulative value before it. So for this one, which is equal to 0.3 minus 0, which is equal to 0.3. And when x is equal to 3, to find the probability x equals 3, we are going to use the cumulative probability for this interval minus the cumulative probability before it. That is 0.4 minus 0.3, which is equal to 0.1. When x is equal to 7, the probability when x is equal to 7, we can use the cumulative of probability in this interval minus the cumulative before it, which is 0.9 minus 0.5 equals 0.5. When x is equal to 10, the probability is using 0.95 minus 0.9, which is equal to 0.05. And when x is equal to 13, the probability can be obtained by using 1 minus 0.95, it is equal to 0.05. After we have got the probabilities for all the possible values of x, now we are going to write the probability distribution function by using mathematical function notation. First, when x is equal to -2, the probability is 0.3. When x is 3, the probability is 0.1. When x is 7, the probability is 0.5. And when x is equal to 10, the probability is 0.5. When x is equal to 13, the probability is also equal to 0.5. Since the probability for x equals 10 and x equals 13 is the same, so we are going to group them together in one row. And so finally, for other values of x, the probability is equal to 0. So this is the probability distribution function for discrete random variable x. Next example, I'm going to discuss how to find cumulative distribution functions for continuous random variable. We have learned that for continuous random variables, the probability is equal to the area under the curve of probability density function. To find the area under the curve, integration is used. This also can be done for cumulative distribution function. For a continuous random variable x, with its probability density function f of t, the cumulative distribution function fx is equal to the area under the curve of f of t up to the value of x. For this, all the intervals of values of x must be considered. Besides the interval from 0 to 1 and the interval from 1 to 5, we must also consider the interval when x is less than 0 and x is greater than 5. For x is less than 0, the cumulative function is equal to 0. When x is in between 0 to 1, the cumulative is equal to the integration of the density function from the lower limit 0 up to the value of x. To avoid confusing of the letter x, the function f of x is changed to f of t. When doing integration, the lower limit is equal to 0 and the upper limit is equal to x, not equal to 1. Even though the density function x power 2 is in the interval 0 to 1, because the area of the cumulative function is up to the value of x, not the whole interval. After the integration, substitute the t with the value of x, and then we got x power 3 over 3. When x is in between 1 to 5, the cumulative function f of x is all the area under the curve before the value of x. So when doing the integration, we should separate into two intervals. One is from 0 to 1. Another one is from 1 up to the value of x. For the first interval, the lower limit is 0 and the upper limit is 1. Then followed by the second interval with the lower limit is 1 and the upper limit is equal to the value of x. Because the cumulative function is up to the value of x, not the whole interval. To avoid getting confused with the letter x, the density function f of x is changed to f of t. After the integration, we will get something like this. So now we are going to substitute the upper limit and the lower limit. For the first interval, the upper limit is 1 and the lower limit is 0. So we get 1 over 3. For the second interval, the upper limit is x and the lower limit is 1. When we simplify, we'll get something like this. Notice that this expression can be further simplified. So when we further simplify into the simplest form, we got this. Now for x is greater than or equal to 5, we know that the cumulative is equal to 1. So therefore, when we put all the result under the mathematical function notation, then this is the cumulative distribution function of x, where when x is less than 0, the cumulative is 0. When x is between 0 to 1, the cumulative function is x power 3 over 3. When x is between 1 to 5, this is the cumulative function. And when x is greater than 5, the cumulative is equal to 1. Next, in this example, I'm going to show you how to find the probability density function from cumulative distribution function for continuous random variable x. For continuous random variables, the probability density function can be obtained by differentiating the cumulative distribution function. When x is less than 0, the cumulative function is 0, so differentiate 0 will be equal to 0. When x is in between 0 to 3, the cumulative function is 1 over 6x, and after differentiate, it is equal to 1 over 6. When x is in between 3 to 5, the cumulative function is 1 over 2, and differentiation of 1 over 2 is equal to 0. When x is in between 5 to 7, the cumulative function is 1 over 4x minus 3 over 4. After differentiate, it is equal to 1 over 4. When x is greater than or equal to 7, the cumulative is 1. So differentiation of 1 is equal to 0. So when using the mathematical function notation to write the probability density function, so fx is equal to 1 over 6 under the interval x is greater than 0 and less than 3. And fx is equal to 1 over 4 when x is 5 to 7. And for other value of x, f of x is equal to 0. So this is the probability density function for the random variable x. In this example, I'm going to show you how to solve the problems of cumulative distribution function. X is a continuous random variable with the cumulative distribution function given below. Find the values of A and B. Since X is continuous random variable, the cumulative distribution function is a continuous function, which is the function f of x is continuous at x equals -1, 0, and 1. When x is equal to -1, for this interval, f of x is equal to 0, and for this interval, f of x is 1 over 5x plus a, and when we substitute the -1 into the x and we simplify, it is equal to -1 over 5 plus a. Since the function f of x is continuous at x equals -1, then these two values is the same, which means -1 over 5 plus a is equal to 0. So therefore, a is equal to 1 over 5. When x is equal to 1, since the function is continuous when x is equal to 1, then the function f of x is equal to 1, and the value is same as this function when x is equal to 1. So when we simplify, it is equal to 2 over 5 plus b. And because of the function is continuous at this point, so means this value and this value is the same. So when we simplify, b is equal to 3 over 5.